Hey there. All right, welcome to recursive and explicit equations. All right, so you can take a look at the learning targets. Basically, it's what I just said. We're going to learn how to write both recursive and explicit equations for both linear and exponential functions. Of course, that's also about arithmetic and geometric sequences. Those are related, so we'll be talking about that. And for the math practice, I just put on make sense of problems and persevere in solving them. It's possible that you may need to do a little rewinding here. I think you really will need to focus on this one, so that's why I put that. All right, hey, let's move on. All right. So I'd like us to take a look here at this table. This is a review of some of the things that we did previously about arithmetic and geometric sequences. Which one's linear and exponential, but what's new here is right here, and this is just terms, the term common difference and the term multiplier, and that's just the name given to the sequence generator for each. So in an arithmetic sequence, it's the amount you add each time. So here they're calling it the difference between consecutive terms. So again, it's just the amount you add each time. And same with the geometric. It's the difference between consecutive terms, but in this case, it's going to be something that you multiply each term by. Another way we actually refer to that is it's the common ratio, so the amount you keep multiplying by. All right, so if you need to stop and take a look at this table for a bit, please do so, because you really do need to know these terms. All right, so I'd like you to do this first. If you see, let me move my face again, in the upper right-hand corner, there's a pencil. That means this is something that you need to do. So call this problem 1 on your work. And for Mrs. Cook's class, I'm going to be putting a Google Doc together. So you can put that on the Google Doc. If not, just title it number 1. All right, get busy on this. Pause the video. And when you're all set, we'll come back. All right, so I hope you took a look at the notes before you tried to do this. I just wanted to remind you that this is the form that we learned earlier this year using slope-intercept. So in this case, the slope is 4, right? And you can actually tell the slope in this case, because if you look at the x values, they're each just increasing by 1. So the difference between them is 1. So all you really needed to do was subtract. The other way I define slope is what happens every time you go to the right one, which would be the same as what happens every time x increases by 1. And you can see even just by looking at the table, it increases by 4, so that's the slope. When x is 0, we have that right here in the table. Y is -1, so it's just y equals 4x minus 1. You really could have done this with any 2 points from the table with methods that we've used before, using y2 minus y1 over x2 minus x1, or I refer to that as delta y over delta x. And then you plug it into the formula to solve for the y-intercept. But in this case, you really didn't have to do that. All right, here we go. We're going to use this equation. All right, so I want you to take a look at this. All right, and this might be where you need to really stop the video and process some of the things that I'm saying, maybe wind it back. But we are going to take a look at the equation we just did and consider it as a sequence. All right, so right here, I've got -1, 3, 7, 11, 15, 19, and of course this is an arithmetic sequence, but we also know that's linear. I've written it in a table that is one you might see more for a sequence. All right, so this is the term number. So term number 0 is -1. So in this one, I'm defining the first term as term 0. Sometimes I'll be defining the first term as term 1, but in this case, it's here. And you can see it's the same table we just had. Really, this would be the x and this would be the y. You could also think about this as a function, right? Basically, this is n, this is t of n. So the function, what do you do to n to get t of n? That's the same as function notation. All right, so what I'd like you to pay attention to here is what the difference is between a recursive equation and an explicit equation. All you need to know for a recursive equation is the sequence generator, or because this is linear in this case, it's the slope. A recursive equation requires you to know the previous term. So here's how we figure it out. Anytime we want to know basically what t of n plus 1 is, we just take t of n and add 4. All right, so let's say we're looking at this one. All right, we've got t of n plus 1. All right, so let's say that I'm going to take a look at 4. Well, 4 is the same as 3 plus 1, right? So here's my 15. So to do that, I'm going to take t of n, which is 11, and I'm going to add 4 to it. So basically, this is just saying add 4 every time your n goes up by 1. Right? Again, that requires you knowing the previous term. The explicit equation in this case, this is actually our slope-intercept form. The explicit equation does not require you to know the previous term. All you have to know is n. All right, so I actually went back to what we did before. Here's the slope-intercept form. I put that in red. If I were writing that in function notation, f of x is equal to 4 times x plus 1. But then if you look at the last one, t of n is equal to 4 times n minus 1. That's the format you would use for sequences. And all that means is, let's say you're on term 4. Well, just do 4 times 4 minus 1. Yeah, that's 15. So the explicit equation is the one in a way we've already been working with. All right. All right, let's take a look at this table. All right, and then I've got some examples here, and I'm going to want you to just stop the video and take a look at this a little bit more. I've got the definition that came right from the text for recursive equations and explicit equations. Note, for recursive, you're required to know other terms. For explicit, you're not. All right, so stop the video, take a look at this, and see if this makes sense to you. And if not, just go back to the previous slide and review that just a little bit. All right, now it's your turn. All right, so call this number 2. I'd like you to look at these 2 arithmetic sequences. I'd like you to write both a recursive and explicit equation for each. And again, if you need to, rewind this video. All right, see you in a bit when you're done with this. Okay, so here are the answers here. So for number 1, note that it says to assume the first term is t of 1, right? So that means we don't actually have the y-intercept here. So you'll see for the explicit equation, we had to figure it out. But I can see that the sequence generator here is 3. So basically all I say here is to get the next term, just add 3. So for t of n plus 1, you just take t of n and add 3. In this case, my y-intercept is negative 11. Right? That's because if this is term 1, really the y-intercept is what happens at 0. Right? Let's think back to slope-intercept form. When x is 0, that's the y-intercept. Well, these term numbers are the same as x. So to get the, basically to get the initial starting point, I had to do 8 minus 3. So that's how I have the 3n minus 11. Right, same here for the second one, same idea. I just added 1.5 each time. So t of n plus 1 is the same as t of n plus 1.5. Note that's also the slope. All right, so basically then for my explicit equation, I'm just putting the slope right here, same as the sequence generator. But then I had to go back again, since this is the first term, I need to figure out the value of term 0. Right, so for term number 0, I'm going to subtract 1.5, so that gave me 0.5. All right, so for term 0, basically it is the value of that term is 0.5. All right, so here's the equation right here. Again, if that doesn't make sense, try rewinding a little bit and see if you can get it. This is just slope-intercept form. All right, so let's move along to the format for exponential equations, and I'm hoping this looks familiar to people. Y equals a times b to the x power. Note that the x variable is an exponent. That makes it an exponential equation. Of course, if you look at this graph down here, we're going to take a look at this. If you're looking at a graph, exponential equations get very close to 0, but they don't usually go below it unless the multiplier is below 0. But note, it grows very, very quickly. All right, so I've got a few terms I'm going to give you here. All right, so first of all, I want you to note we have a table very similar to what we did before, right? And here's your term number. Here's the term for that number. Take a look at this, all right? Here is my geometric sequence. And I'm back to thinking about this one now as the first term. In order to actually figure out these equations, I really need to know this one right here. Just like we need to know the y-intercept for linear equations, we also need to know the y-intercept for exponential equations, and that is also what happens when, basically in this case, n is 0. If I had this as x and y, it would be what would happen when x is equal to 0. So you're going to see me using those interchangeably. All right, so right here, let's look back up at this. Here's how we figure it out. The letter B here is the common ratio, or we could also call that the multiplier. So we figure out what we keep multiplying by, right? Since we keep multiplying by the same number, that's our base number. Think about that for a second. If you keep multiplying, in this case it's by 5, then 5 is the base. We're going to take 5 to a power. All right, so I know then that in our situation, B is equal to 5 because that's what we keep multiplying by. Then, in order to get the explicit equation up here, you also need to know the initial condition, or what T of n equals when n is 0, right? So that's why we need this 0. This is going to become part of the equation. So the important numbers are, what are we multiplying by? And basically, what is the value when n or x is equal to 0? All right, let's start with the recursive equation first. All you need to know here is the sequence generator. So that's 5, because that's what we multiply by. So t to the n plus 1 is just going to be 5 times the term before it. That's all you do. You just keep multiplying by 5. For the explicit equation, you need to know the multiplier. In this case, it's 5, and the initial condition. In this case, it's 1. Right? Since it's 1, that makes this a little bit easier to solve. So if I were writing it using this form, I would say the equation is y equals 5 to the x, right? And if you look at that, oh yeah, that works, right? Like this would be 5 squared. This would be 5 to the 3rd power. If you're using this format for sequences, t of n is just equal to 5 to the n. All right, let's take a look at another one. All right, so I've made some things a little bit more clear here. First of all, I want you to look at this. All right, the initial condition here is 3. I have to ask a little question here. How can you determine the multiplier? It's not quite as obvious in this case, but yeah, here's how you do it. You take one term and you divide it by the term before it. In this case, it's 4. Of course, you know, it might have been easier to look at like the 12 and the 3. All right, so our equation for the recursive equation is just 4 times the previous term, because that's our multiplier. Right? But then for the explicit equation, remember this is the form here, our initial condition is 3, right? Basically, that's when n equals 0, so that's right here. And then times basically 4, which is our multiplier to the x power. This right here, though, would be the form we would use when we're doing sequences. All right, if you're stuck on that, rewind. All right, you should pause the video. Take a look at this for a minute. I'll let you read that on your own. Right, now this is for you to try. So pause this and give this a shot. And when you're ready, come on back. All right, and here are the answers here. I want you to double check your own answers. Right, remember you should be finding the multiplier by dividing, right, in order to get these here. Right. And if you find what you're multiplying by, that's used in both. And then for the second one, we did have to find what happens when n equals 0. All right, so take some time. If you're really stuck, go back and review. All right, and as always, don't forget to hand your work in. For some of you, that's a Google form. For some of you, that's your own notes. Hey, thank you for listening. Hope you have a great day.